Okay, so this problem says to let h of t equal tan of 4x plus 7, and we want to find h prime of 3, first of all. So to find h prime of 3, we first need to take the derivative. I would notice that the outside function is our tan, and on the inside function we have more than just x. So if we first write down our derivative of tan formula, the derivative of tan of x is equal to secant squared of x. So in our first step of finding h prime of t, we will take the derivative of the outside function first, which is our tan, and that becomes secant squared. And instead of writing x, we write what's the inside function, is the 4x plus 7. But then because of the chain rule, we also have to multiply by the derivative of the inside function. So the derivative of 4x is 4, and the derivative of 7 goes to 0. So it would just be times 4, which simplifies to 4 secant squared of 4x plus 7. So this is our derivative, but to find h prime of 3, we need to plug in 3. So that gives us 4 times secant squared of 4 times 3 plus 7, which is 4 secant squared of 4 times 3 is 12, plus 7 more is 19. So this would be the exact answer. If you wanted to plug this into your calculator, make sure that it's in radians to get a decimal. But this would be our first answer, is 4 secant squared of 19. And also, you probably won't have a secant on your calculator unless you're using an online calculator. So you'll need to use that secant is equal to 1 over cosine in order to simplify. So then, from here, to find our h double prime, we need to start back with our original derivative, which is our 4 secant squared of 4x plus 7. Now, in order to take this derivative, let's rewrite the first derivative as 4 times, because this squared here means that we're squaring the entire secant. So it'd be secant of 4x plus 7, and then all of that would be squared. So now, if we take our second derivative, we will have this time, because we have a squared here, we need our outside function would be the power rule. So we can use our outside function as a power rule first. The 2 times 4 is 8, and then we leave the inside function the same, is the secant of 4x plus 7, and then we subtract 1 from the exponent to make it a 1, so that means we don't have to write it. But then we have to multiply by the derivative of the inside. So since the derivative of the inside is more than 1, like it's going to be another chain rule, let's first just write this as times secant of 4x plus 7, the derivative of that. So bringing this down, we can just bring down the 8 secant of 4x plus 7. And then now we're multiplying by, if we're taking the derivative of secant of 4x plus 7, now we have another chain rule. So we have the outside function now is our secant function. So using our formula, let me write it over here, the derivative of the secant function is secant x tan x. So now, since our outside function is the secant function, we'll take the derivative leaving the inside the same. So this will be secant of 4x plus 7, and then times tan of 4x plus 7. But now we have to, that 7 didn't look quite very good. There we go. And then times the derivative of the inside, which again is the 4x plus 7. So the derivative of 4x plus 7 is 4. So now we have this whole big long equation or expression. We can bring the 4 to the front. 4 times 8 is 32. And here we have a secant of 4x plus 7 and another secant of 4x plus 7. So we could write that as secant of 4x plus 7 squared, or bringing it in to write it in the simplified notation is secant squared of 4x plus 7, and then we still have this times tan of 4x plus 7. So that would be our second derivative, but we're trying to find the second derivative at 3. So we need to plug in 3, and we get that h double prime of 3 is equal to 32 secant squared of 4 times 3, and I'll go ahead, we know that 4 times 3 plus 7 is 19, so I'll go ahead and substitute that in, is secant squared of 19 times tan of 19. And this would be our h double prime of 3. We could again find what this is in a calculator to find the decimal approximation, but this is the exact answer. Okay, so I hope this step-by-step solution was helpful for you. If it was, please like the video and share with anybody who you think would find this helpful. Thanks.